Hi girls. Okay, so this is our last part of normal distribution. We're so nearly there, but obviously we lost the lesson on Friday. So there's not much to go through. It's all about finding a missing mean or a missing standard deviation, or occasionally you'll be asked to find both that are missing. But it's still a lot of kind of reading the tables backwards. So you'll get questions that look something like this. I mean, again, it will be part of a longer exam question. But we've got x is normally distributed with a mean of mu. We don't know what the mean is, standard deviation of 3. Given that the probability that x is greater than 20 is 0.2, find the value of mu. So find the mean. Now, again, remembering that our tables are for z, where the mean is 0 and standard deviation is 1. So whilst we are given the probability that x is greater than 20 is equal to 0.2, that has been coded from the standard normal distribution z. So what we need to find is the value of z that gives us the same probability. So we're trying to find this value z, little z, that gives us the probability of 0.2. Our percentage point table, we can use this one. Remember, the percentage point tables are all greater than. So we can look for 0.2 in the table, which is here, which gives us the value of z is 0.8416. So our little value of z is 0.8416. Now we can undo the code. So remembering that the code is this value of x minus the mean divided by the standard deviation. And that would give us the value of z, which we've just found is 0.8416. So we have 0.8416 is equal to 20 minus the mean, which is what we're trying to work out, divided by the standard deviation, which in this case is 3. And then we would solve that equation to work out what the mean is. So multiply by 3. I need to work that out. 416 multiplied by 3 gives us 2.5248 is equal to 20 minus mu. I'm going to rearrange that to get mu is 20 minus 2.5248, which is 17.4752. If we round to 3 significant figures, is 17.5. And that's it. Okay, so this part in my working out, this bit here where I worked out what z is kind of there just to show you what I'm doing. It's not essential for your working out in an exam, but definitely for me helps me remember what I'm actually looking for. So I know the probability when x is greater than 20 is 0.2, but I need to find the value of z that gives me the same probability in order to then use the code and undo the code to find what my mean actually is. We can do something similar to find the standard deviation. So here we have a machine makes metal sheets with width x modelled as a normal distribution, so that x is normally distributed with a mean of 50 and a standard deviation of sigma. This time we're trying to work out what sigma is, what the standard deviation is. So again, we're given a probability that we can work with. This one is not going to be in our percentage point table, so we're going to have to use the main table to work it out. Given that the probability that x is less than 46 is equal to 0.2119, find the value of sigma. Now, because our probability is less than 0.5, again, this is where a sketch, for me, again, visual learner, a sketch makes sense. So there's my normal curve. if my probability is 0.2119, it means I'm looking at something down here, because everything below the y-axis is like 0.5 up to 0.5, and then so kind of from here to there is probability of 0 to 0.5, and then above is 0.5 to 1. Because our probability is less than 0.5, it means we're looking down here, which means my z value is going to be negative, and I can't get any negative, what am I trying to say? I can't get negative values of z in my table. There are no negative values. So what I need to do is find a similar probability, use the symmetry on the graph to identify something that I can find in the table. That's what I'm trying to say. This would give me the same probability with a positive value of little z. However, this is not in the percentage point tables, and the big table, the normal distribution table, is all less than. So actually what I'm trying to find is the probability that z is less than some little z, which would be equal to 1 minus 0.2119. And that's what I can look for in the table. So 1 minus 0.2119 is 0.7881, and then I would find that in the table. The only thing I'm sorry, I'm looking at the wrong example up just to check I'm doing the right thing, to make sure I don't make a mistake. I was looking at the wrong one. So if I go to my percentage point table, I haven't copied that into the slide into this slide because it's too big. But if I go and find 0.7781, that gives me little z is 0.8. However, we were in the negative part of the graph, of the distribution. So my z is negative 0.8. Don't forget to make sure you've got the correct sign, whether it's positive or negative. So my little z is negative 0.8. And again, I need to put that back in. I need to put it into the code and reverse the code in order to find my standard deviation. So I have negative 0.8 is equal to this value 46 minus the mean that I'm given, which is 50, and divided by the standard deviation, which in this case, we don't know, we're trying to work it out. If I do a cross multiplication, I'm multiplying the sigma up and the negative 0.8 down. So I end up with sigma is 46 minus 50 divided by negative 0.8, which is, let me type it into my calculator, 46 minus 50 divided by negative 0.8 gives me a standard deviation of 5. Again, let me just check that is right. Sigma is 5. There's also this is only part A. There's also part B, find the 90th percentile of the width. So now that I have my normal distribution, so X is normally distributed with mean of 50, standard deviation of 5. Now I can use that to work out a value. So 90th percentile means I'm looking for the probability that X is less than A is equal to 0.9. I can use the percentage point tables here because if the probability that X is less than A is 0.9, the probability that X is greater than A is 0.1, which I can find in the percentage point table. Can I pop it in just really quickly? There we go. So the probability that X is greater than A is 0.1. Look for that in the table. So 0.1 is here. That's the rubber, not the highlighter. So we end up with A is 1.0 yeah, so my value of A, yeah, maybe I should be a bit more clear with my letter in here. This is actually, because I've used a table, this is actually Z. So for my Z value of A, I get 1.2816 that I then need to code that to put it into, yeah, to put it in terms of X. So I get 1.2816 is equal to my value X minus the mean, which is 50, divided by standard deviation, which is 5. Rearrange that until I get, so multiply by 5, 2816 multiplied by 5, and add the 50 across. Yep, gives me X is 56.4. Again, that's to 3 significant figures. I rounded it up. Yeah, that's it. So kind of using part A to find the standard deviation, and then part B is then using what you found in order to answer the same types of questions that we were doing last lesson. Okay, last one is when both are missing, when you're missing both the mean and the standard deviation. We can use the percentage points table for this one. So we have probability that y is less than 160 is equal to 0.99. That means the probability that, now remember we're looking for a value of z. We have all the information there for y, or whatever it is, in this case it's y. But what we want to find is a value of z that has the same probability, so that we can then use the code to get back to what the mean and standard deviation is. So we're looking for a probability of z where it's less than a certain value to give us a probability of 0.99. That's not in the percentage points table, but 0.01 is, which is the same as doing the probability that z is greater than some value little z is 0.01. I can find that in the table. It's here. So my value of little z there is, I'm going to say z1 because I'm going to have to do this twice. So my z1 is 2.3263. That's my first value. I'm going to have to use the code on that, but first I'm going to deal with this second probability they've given us, and I'm going to be doing the same thing. So some probability is greater than little z2 is equal to 0.9. Yeah, if for this one, again, 0.9 is not in the table, but 0.1 is, and because of the symmetry in the graph, if we can find the z value for 0.1, then the z value for 0.9 is the negative of that. So our value of z2 is, find 0.1 in the table. It's here, 1.2816. And we take the negative value of that because we're actually interested in 0.9, not 0.1. So negative 1.2816. Now we've got two values of z, which we can put into the code and set up simultaneous equations, basically. So we have, using the first, we have 160 minus the mean divided by the standard deviation gives us 2.3263. We also have, using the second probability, 152 minus the mean divided by standard deviation is negative 1.2816. Rearrange that until you get two linear equations. So we get 160 equals 2.3263, wrong one, sigma plus mu. And the second equation is 152 equals negative 1.2816 sigma plus mu. They're linear equations, so you want to either add them together or subtract them. We have the same value of mu in each one. We've got 1 mu in each. So I'm just going to subtract these equations from each other. I'm going to do, if I call this 1 and this 2, I'm going to do 1 minus 2. So 160 minus 152. Usually I'm running out of space. Usually I would set these out where I put one on top of the other just to make it, that's how I've always done my working out, but I'm running out of space to do that. So I'm doing 160 minus 152 gives me 8. And then I'm doing 2.3263 minus, so subtract a negative, which becomes a plus, 1.2816. That gives me 3.6079 sigma, and then the mu's got cancelling each other out because we're subtracting. 1 mu from 1 mu is 0. I can divide 8 by 3 point whatever, gives me sigma is 2. I'm going to round it to through 2 decimal places, 3 significant figures. Gives me 2.22 is equal to sigma. So my standard deviation is 2.22 to 3 significant figures. I'm then going to use that to work out the mean by substituting it back into any one of my equations. I'm going to just use the first one. So I'm going to substitute it back in here. So 160 is equal to 2.3263 times 2.22 plus mu, 2.3, all these long decimals, 263 times 2.22 is 5.164386. I'm going to subtract that across the other side from 160, gives me 150. If I go 3 significant figures again, 155 is equal to, sigma is equal to mu. So my mean is 155 and my standard deviation is 2.22. But essentially what we've done is the same thing that we did in the previous 2 questions, but twice, and then use that to set up 2 simultaneous equations and solve those in order to calculate mu and sigma. Don't be put off by the fact that your simultaneous equations are dealing with big decimals. You're talking like 4 decimal places. You have a calculator. Like, that's not something to be afraid of, for want of a better word. Like, you can deal with decimals. You have a calculator. It's still just algebra. It's a linear simultaneous equation. It's the most basic type of simultaneous equation that you can get, and you've been doing this since year 11 and you can do it well. So the setting it up is the difficult part. Once you've done that, the actual solving the equations should be pretty straightforward. But then that's it. On the slides, there's 2 test your understanding questions, obviously with the solutions there. So you're getting on to like slide number 10 on the last one I posted, which was called normal and coding. So if you want to try the test your understanding questions, and then there's obviously the exercise from the textbook to finish this topic off. What I will do is send you some exam questions as well, so you can have a go at applying this in an exam question context. And I definitely have, I'll send you the link for it as well. I definitely have video solutions to those exam questions, because there were a few that were quite tricky when we did them last year. So I made a video kind of talking through the solutions. So hopefully that'll help, but that is statistics finished. And now we can just keep going back and revising the bits that we need to. So yeah, I hope that helps. Let me know if you have any questions. I appreciate this is quite difficult, and going over it via video, maybe you might have some questions. Please feel free to email me, ask me in class. However, let me know if you have anything that you're unclear of. But yeah, well done. I think we deserve a round of applause for finishing statistics off. Right, thanks for watching this, girls. I hope it helps.